So we can use the old school techniques from chapter 2, or you can use L'Hopital if you have 0 over 0 or infinity over infinity. So it's up to you what technique to use. But now that you have L'Hopital and derivatives, that technique is a lot easier. If you're comfortable with the derivative of the top and bottom, of course. So right now the limit is going to be 0 over 0, indeterminate. Therefore, we can use L'Hopital. It's a little bright. Is that better or? Okay. So if we do L'Hopital, we would get the derivative of the top and a derivative of the bottom, which would be derivative of the bottom is easy, right? It's just a 1. Derivative of x is 1. Derivative of -1 is 0, so that part will be gone. So all we have to deal with is this derivative, which will be 1/2 x plus 1 -1/2 times the derivative of the inside, which is a 1, but that doesn't really matter, right? So this will be a chain rule technically. I skipped the derivative step. Do you guys see this, or should I do this on the side somewhere? Is that clear?
I think it's clear.
Okay. So then at this point, just plug in the 0. We should not have any more problems. So the limit will be, I'm going to leave it just as is to avoid algebra because we don't really need to do it right now. Right? So this would be 1/2 times 1 times 1, which is 1/2. So the limit will be 1 over 2. So if you were to have used the conjugate or something like that, you would have got a 1/2 anyway. If you were to have used the estimating process where you have where you plug in values closer and closer to 0, you remember doing that? You'll be approaching 1/2 from both directions. Any questions on number 1?
No, sir.
Okay. Number 2, it's another limit. This one looks like more of a traditional chapter 2 question. Just find the limit algebraically or analytically. Okay. Next, approaching 14 from the right or the positive side. X minus 3 over x minus 14. Okay. So we're approaching from the right. So this means we should probably graph and see what's going on. Clearly we can't plug it in straight up, right? Because it makes 0 in the denominator, but not on the top. So I say graph it. I've also turned on Desmos for your final, so you should be able to open it up once it's time. So let's do x minus 3 on top, x minus 14 see what's going on. So where's 14 at from the right side? If you can't see it, you can always say x equals 14 and make a little dividing line, right? So as we come from the right to the blue line, which is 14, we shoot off into infinity, right? So I'd say an explanation. So I would just say 14 by examining the graph. I'm sorry, I should say infinity. I don't know why I said that. Okay. Examine the graph. On the right side.
And when it's a plus sign, it means it's approaching it from the left, right?
Yeah, plus means from the right side because it's a positive direction. Minus means
Oh, okay. Okay.
negative side.
Thank you.
Okay, now if you do it algebraically, you can like multiply by stuff or try to factor. That's what they mean by algebraically. Analytically, can be either by with the graph or multiplying by or examining the values closer and closer to 14 on the right side. Like if you were to have plugged in, let's say 13.9 and 13.99, and you do that a few times and you notice it's getting large, then you can just explain that as we get closer to 14, it goes to infinity. Or you can just sketch a graph or explain it and just say, well, this is what the graph looks like. Clearly, we're going to infinity at 14 on the positive. Does that make sense? Like how to get your point across? And number 3, we're not going to have any mean value stuff. If you see one, then don't worry about it. I'll just skip that problem. Number 4. There shouldn't be one, but I'll double check. Find the relative extrema of f of x equal to negative 9x squared plus 54x plus 2. And it tells you to use the first derivative test. So that's what we're going to do. If it doesn't tell you, you can use whatever method you want, first or second. All right, so we're going to need the derivative. It's going to be just basic power rules, right? Nothing crazy. So that'd be negative 18x plus 54. To get critical numbers, we need to set this to 0. So set to 0 for the criticals. So negative 18x plus 54 equal to 0 is the same as negative 18x equal to negative 54. So x will equal, what will x be? Looks like 3, right? Yeah. There's a critical number. Now, we'll need to test around the critical number. Okay. So we only have one. So we gotta test both sides. So I'm gonna pick an easy one over here. 0 and something as small as possible, 4. All right, so f of 0, derivative at 0, is going to be 54, right? Plus f at 4, f derivative will be negative 18 times 4 plus 54, which will be what? I believe that's negative. Yeah, because that's 318, so negative 18. Right? So there's my first derivative test. I plugged in the numbers around the critical point, critical number. So I have increasing, decreasing. Right? So drawing scrappy. Anyway, whatever. So we have a maximum, right? Now look at the answers. We know it's going to be at 3 because that's a critical number we found. So it has to be one of these, but we know it's a max, so it has to be 3 comma 83. But if these numbers, let's say we needed to know this number, we got to plug it into the original. So let's go ahead and say that here. Amount of space, so f, plug in f of 3 to the original equation, 18 times 3 plus 54.
Negative
Oh,
9
that's not
x
the
squared.
original. What's up?
Nothing. You found it.
Oh, thanks, man. Appreciate it. I almost missed it. I was like, wait a minute, 0, it's only on the derivative. So it'll be negative 9 times 3 squared plus 54 times 3 plus 2. So, what the heck is that? Let's see. It's 9 times 9 is negative 81 plus 54 times 3 plus 2. 83. Okay, so maximum at 384. I ran out of space, but is that clear or no? Okay. All right, number 5. And limit. That looks like infinity over infinity, right? So there's a few things you can do here. So we can do L'Hopital. Right, do it one time. L'Hopital will give us the limit as x approaches infinity. Do the derivative of the top. That will be negative 8 over minus 10x, right? But now as the bottom grows to infinity, this will be 0. So now it's obvious that it will be 0. Here it is also obvious if you explain it. I will accept it. If you say, well, the denominator has a higher degree, right? So this denominator will grow faster and the entire thing will go to 0. Here is, you're basically proving that. But I'll accept either one as long as you explain it. Any questions on number 5?
No, sir.
Okay, just let me know if you miss, if something seems weird, just let me know. Okay, number 6 is a word problem. The radius r of a circle decreasing at a rate of 5 centimeters per minute. Find the rate of change of the area. The area A when r is equal to 6 centimeters. So we're dealing with circles and area. So nothing 3D. Area of a circle we agree is pi r squared, right? Okay. If we take a derivative of this implicitly, so d with respect to time, we will get dA dt equal to 2 pi r dr dt. So we know they want us to know what's going on when r is equal to 6 centimeters. They told us the rate is decreasing at 5 centimeters per second. So dr dt should be, I'm understanding -5 centimeters per minute since it is decreasing, right? Negative rate means negative slope. So plug all this in and we should be good. So dA dt would be 2 pi times 6 centimeters times -5 centimeters per minute. So 2 times 6 times 5, that's going to be what, 60? -60 pi centimeters times centimeters is squared per minute. That wasn't too bad. That was going to be stranger. Yeah, there it is. So all you have to do is take derivative of the area formula and plug in what they gave you. That is all you had to do. Any questions on the approach or the ideas?
No, but that looked way harder than it seemed.
When I read it too, I thought it was gonna be harder. I was like, I was worried because I don't usually practice this ahead of time. So like, man, I hope I don't get stuck on something. But anyway, but it makes sense though, right?
Yes, sir. Thank you.
Yeah, sometimes they're not too bad. Sometimes. Let's see here. Find a point. This one's weird. Check this out. Find a point on the graph of the function square root x that is closest to the point 18 comma 0. Okay. Interesting. Find a point on the graph. That is closest to oh wait, hold on. Of the function f of x equal to square root x. That is closest to 18 comma 0. Seems like a really strange question, but let's see what's going on. Let's graph this. So you have a function equal to square root x. All right, there it is. They want to know what point on that green function is closest to this point. Okay. What is the closest thing to it? Interesting. Okay. It sounds like we should be minimizing distance, right? So we might need the distance formula. So let me go grab that real quick. Let's see. So this is what I'm thinking. Like, well, we remember how we talked about optimization, like optimizing profits or minimizing cost or whatever waste. Remember, I think we had when we cut out pieces of the box or something. Minimize the material used to build a fence, all that stuff. So to me, when I'm hearing what is the closest, I'm hearing you want me to minimize the distance because that would be the closest, right? Alrighty. And we're gonna use well, let's get rid of the square root because right now this is kind of annoying to deal with. So let's say if we square both sides, we're gonna have d squared equal to this, right? Okay. Now we're going to plug in this point here as our x1, y1. We want to figure out what the heck is the x2 and y2. That's the goal, because this would, if we minimize that, then we'll solve for those values. Okay. So basically, take the derivative of this formula and set equal to 0. This is what we're going to do. But first, let's plug in the numbers. So that'll be I was going to call it x because it's sum x plus 0 minus some, y minus some 0. Now this d squared is kind of weird. We can call it whatever we want because all we need to do is take the derivative of this and set it equal to 0. The y though is a little annoying. Remember that f of x is equal to y, which is equal to root x. So let's use that fact to get rid of the y. That way we don't have to do an implicit problem. You see what I mean? So they told us that's what y was here. So I'm going to use that in the problem. They told me what the x1, y1 was here. So I'll take a derivative of both sides and set it to 0. I'm going to put brackets here. It's one derivative of both sides. So and then you have to set it to 0 to find the critical number. So that will be 2 times x minus 18 times 1 plus 1. That will give us 2x minus 18 times 2. What is that? 36, right? Plus 1. So that will be solve for x. Move that 36, negative 36 plus 1 is negative 35. Add that over, we get 35 over here. So x is equal to 35 over 2. So this is the minimum point. Okay. Now plug that into the original, and we should have our y value. It's a weird question. So let's look at our answers. Hopefully we got this correct. Let's see. So 35 over 2. So it has to be A, B, or C. I have square root 35 over 2. So if you were to rationalize that, right, by multiplying top and bottom by root 2, you will get the top answer. So that's the y value. So the answer will be 35 over 2 and square root 70 over 2. Any questions about any of the steps? Notice how this left side didn't really matter. Because I'm going to set it to 0 anyway, so it's like, who cares? Let that be 0.
Are you adding is that like a square root of 35 over 2, or did you like point to see it? Because I'm on my phone, it's hard to see.
Yeah, so this is square root 35 over 2. So when you plug in this guy, 35 over 2 into square root x, you get this, right?
Yeah, are you adding it to the square root of 2 over square root of 2?
So you multiply you multiply by root 2 over root 2 to
Okay.
rationalize.
Okay. Yeah, just couldn't see. All right, thank you.
Any other questions on number 7? So whenever you hear like minimize, oh, what's up, Nicholas?
Where did you get rid of the negative 35 from?
He wants to know how you got the 35 when it went from negative 36.
Well, negative 36 plus 1 is negative 35, right?
Yes.
And then you add it over to this side, it's positive.
Oh, okay. I missed that part.
Now you're good, man. I think the hardest part is knowing what formula to use and what you're trying to do. When I first read it, I'm like, okay, what are you talking about, right? So what I recommend is whenever you hear minimizing, maximizing, lowest or closest, that is an optimization type problem. So you need to figure out what formula you need to take a derivative of and set it to 0 and solve for that x. Like we did with the length and width problems. Remember back in, I forgot what chapter that was, chapter 3, I think. We had to minimize length or the area or whatever, and we would find the best width and length that give you the maximum area or minimum area or whatever the problem's asking for. Does that make sense? So just make sure you bring a bunch of area formulas for basic shapes, distance formula, just to be safe. Bring that with you. All right, let's do the next one. If you guys have no other questions on 7. Just cool on this page.
Yes, sir.
Let me know. Number 8 says find all points of inflection. F of x is equal to 1/2 x to the 4th plus 2x cubed. So the derivative will equal 1/2 times 4 minus 1. Right? Which is going to be 2x cubed. So another derivative is going to be 6x squared. All right. Oh crap, forgot the other piece. My bad. Let me redo that. I don't know why I only wrote one part.
I was gonna say, did I miss something?
Yeah, I'm just really hungry right now and I'm not thinking straight.
felt that.
Let's see here. That's right. Got some food ready in the oven after this. Let's see here. First derivative would be 6x squared. Then one more would be 6x squared plus 12x. Okay, so set this to 0. Factor yours x, and 6 is in common. That goes x plus 2. So x is 0, x is -2. Okay. So plug that into the original to get the points, because it said it wants the points. So we need the x and the y. F of 0 will be 1/2 times 0 to the 4th plus 2 times 0 cubed, which is 0. F of -2 is equal to 1/2 times -2 to the 4th and 2 times -2 cubed. So that will be -8. No, actually, yeah, 8 minus 16, -8, yeah, negative. So the answers would be 0, 0, and -2. Yeah. Okay, hold on a second. Sorry, my daughter's bothering me. -2, comma, -8. There it is. Okay.
What does that say? Oh, the answer. Okay.
Yeah, just answer A and S. Let's look at our answers here. 0, 0, and -2, -8. Yeah, so D. Any questions on number 8? Okay, so pretty straightforward. Number 9 says just find the derivative. That's it. Okay, so the function is going to be x to the 8th times the square root of 5 minus 3x. So this is going to be a product rule, but also you're going to have a chain rule for this piece. Right, so I'm going to rename this y just so I can use my notation that I like. So the first one will be x to the 8th. And the second piece will be g square root 5 minus 3x. The derivative will be 8x to the 7th. Derivative of this guy will be 1/2 times 5 minus 3x, -1/2, times the derivative of the inside, which will be 3. -3. Any questions about this chain rule? Okay, so let's put it all together, right? The derivative of y will be the product rule, f times g, f prime g plus g prime f. So that will equal 8x to the 7 times g plus g prime, which is that negative piece, times the f. Sorry, f is 8x to the 8th power. There we go. All right. So this is pretty much the answer, but with multiple choices, combine these into one fraction. So theirs looks different. So the denominator needs to have this over here in order to add them together. So what I'm going to do, a lot of space here, do it down here. Multiply top and bottom by this guy. This will become minus because of the -3 here. So minus 3x to the 8th over 2 square root 5 minus 3x. Shoot, I need a 2, right? So I should put a 2 here and here. Okay, so these square roots will cancel out. This 2 will make that a 16, and then I can combine these together. So I'm going to have 16x to the 7 times 5 minus 3x minus 3x to the 8th over the common denominator. Okay, distribute this stuff here. Yeah. 16 times 5, what's that going to be? 16, double check, yeah, it's 80, right? 80 x to the 7th minus 3 times 16, that will be 48 x to the 8th minus 3x to the 8th over 2 square root 5 minus 3x. These combine into negative, what, 51, right? Okay, finally, looks like the answer will be D. See how they combine into one fraction and then they factor the top. So if I factor x to the 7th, I'm going to have this. But if you show all your work and you pick the wrong answer, who cares? Just make sure your work is good. Okay. Nick, if you got to here and you moved on, then I would give you most of the credit for this part. Okay, this is just some algebra, some extra steps. Any questions on number 9? Okay, let's do number 10. Determine the open intervals on which the graph of y equals negative 6x cubed plus 8x squared plus 6x minus 5 is concave down or concave up. So we're going to need the second derivative. But we're going to need the inflection points and the second derivative. Okay, so first derivative will be 3 times 6 is going to be 18. 2 times 8. And that'll be 6, right? First derivative. Second will be, what is that? 36, right? Negative, yeah, negative 36x plus 16. Interesting. Okay. Set that to 0. Define the inflection point. So negative 36x equals negative 16. Solve for x. That looks like negative 16 over negative 36, which will give us 4/9, right? Okay. So we want to know what happens before and after that inflection point. So pick a number right after. So second derivative at 1. 4/9 would be less than 1, so I'm going to pick 1 right there. And 0. So double derivative will be negative 36 times 4/9 plus 16. Will that be positive or negative? Oh shit, why did I put 4/9? So negative 36 plus 16 is negative 20. So we are concave down over here. Okay, now second derivative at 0 would give us a positive, right? So we are plus. So you would say concave up on the interval negative infinity to 4/9. Concave down on 4/9 until infinity. Does that make sense? Any steps that don't make sense, please let me know.
I have a question. How come on well wait. It's positive 4/9, right? You always left it as positive 4/9, so you didn't put it as a negative.
It should be positive.
Okay. I was trying because I for some reason I thought I heard you say negative 4/9, so I was like, where'd you get the negative from? Okay, thank you.
No, you're good. You're good. Yeah, the negatives cancel. I meant 4/9, so. Let's see here. That's number 10. Number 11. So find dy dx at 3, 1 for the equation x equals y cubed minus 6y squared plus 8. Okay. So I guess take the derivative implicitly. So d dx of both sides. So that will be 3y squared dy dx minus 12y dy dx plus 0. Now it tells us to solve for dy dx at 3, 1. So let's first factor dy dx. So now I have 3y squared minus 12y. Plug in y, and we will have 3 times 1 minus 12 times 1. So that will be 1 is equal to dy dx times -9. So divide by -9, so that gives us dy dx equals to -1 over 9, which is C. So all I have to do is take the derivative, plug in the numbers they give you, and isolate dy dx, because that's what they asked for. Any questions on these steps? Okay. We move on to 12 then. Number 12 is a summation problem. So we're gonna need the summation formulas for your exam. So rewrite the series without summation notation. So the sum from I equals 1, 2, and to n of 24 I times 1, no, times I minus 1 over n to the 7th. Okay, so I'm going to distribute the 24i. Actually, first I'm going to pull out 24 and pull out n to the 7th. So now I have I times I minus 1, which will give us, I guess I could write it here, 24 over n to the 7th summation of I squared minus I. I'll separate these into two series. Put some brackets out here, I guess. First series with a I squared minus the second series with just an I. So we're going to need the formulas for I squared and I. I don't have those memorized, so let me look them up. Here it is. So I squared, so this first piece is going to become n times n plus 1 times 2n plus 1 over 6. And then minus the I is going to become n times n plus 1 over 2. So this is just from the formulas, right? Okay. Let's go.
Is that a N or a X?
There's no x's.
Oh, so it's 2N?
Right here, yeah.
Okay.
Okay. So this needs a 6. So multiply by a 3 there, and then start combining things. Yeah, I'm not going to multiply just yet. Although I noticed that there's an n in common and an n plus 1. That worth factoring. Let me see. 1 second. Yeah, I'm going to factor that n out. Okay. So it's 24n over n7 over here, which reduces, right? So now I have n plus 1 times 2n plus 1 minus, multiply by 3 over 3. That gives us 3n times, there's no more n. 3 times n plus 1. All over 6. So I combine the fractions. So now multiply this out and see if anything cancels. And 6 goes into 24, right? So you could cancel that guy. That'd be cool. 4 times. So So now all we have out here is a 4/n7 times, multiply this nonsense right here. That'll give us 2n squared plus n plus 2n plus 1 minus 3n minus 3.
Did you move that n on the outside?
I factored these ends right here. Right there. And it cancels
Yeah, that's
one of these here, which leaves us with a 6 there. And then this 6 divided to 24, leaving us with the 4. Trying to make it as pretty as possible. I mean, we've technically already answered the question, but we're doing algebra now. 2n squared, n plus 2n, right? That's 3 minus 3. So these cancel with this. 1 minus 3 is a -2. Okay. So final answer, multiply that nonsense back in, that will give us 8 n squared over n6 minus 8 over n6, which reduces to 8 over n4 minus 8 over n6.
for the one that has a -3. How'd you get the 3 on that one?
This 3?
Go up.
Here.
Yeah, how'd you get the 3 there?
Oh, you're gonna have to do 3 over 3 to get the same denominator in order to combine them together. So that makes it a 6, and this turns into,
Oh, okay. I see what you're saying.
yeah, I
just
skipped
like-
a fraction step in the middle here.
Nah, you're good.
Okay. But it looks like the answer is E. Any questions on the steps? Does it make sense? Okay. 13. It's an integral. Evaluate the integral. Okay, so you gotta integrate each term and then evaluate the bounds. Remember, it's top minus bottom, right? So that will be 5x squared over 2 plus 4x. So you do 1 plus 1 over 1 plus 1. You guys remember the integral step?
Yeah.
Okay. I didn't write the 1 plus 1 this time, so I'm assuming you guys are a little more comfortable with it now.
I did after I studied the heck out of the last review. Now it should come naturally.
Nice. Now you're a pro.
Oh yeah. I mean, I've tried to I wouldn't say memorize that problem, but I would try to understand the steps. I'm like, okay, so how is it familiar to the next one?
That makes sense. Trying to get a feel for the idea. Okay. So top minus the bottom. So this will be 3. So 5 times 6 squared, that's going to be 36 times 5. Divided by 2, that is going to be 90. 4 times 6 is 24. minus 9 times 5, that's 45 plus 12. So 90 plus 24 minus 45 minus 12. So that will be 57, right? Wait a second. I forgot my 2 down here. Son of a biscuit. There we go. So that should be fine. It's just not as pretty, so we're gonna get a decimal to punch into our calculator. That should be 79.5. Let's check. 90 plus 24 minus 12 minus 45 over 2. Yeah. Sorry about that. Any questions on those steps there? Not too bad. Okay. Find the area of the region bounded by the graphs of y equals x cubed plus x equals 4, y equals 0. Okay, let's go ahead and graph it on our Desmos here. Okay, so we're gonna have y equals x cubed plus x equals 4, y equals 0. So zoom in. Looks like we care about this section in here. So from 0 to 4, we're going to integrate underneath this cubic function. So integral from 0 to 4 of x cubed plus x dx. So that will be x to the 4th over 4 plus x squared over 2 from 0 to 4. Okay. So that will give us 4 to the 4th over 4 plus 4 squared over 2 minus 0, which will be 64 plus 8. Let's see. Yeah, 72. Any questions on 14? All right, let's do the last one and then we'll stop there for the day. This is actually just a formula that uses for the inverse sine. Oops, sorry. Find the derivative of f of x equals 10 arc sine the derivative will be, so this is when we need our formula. So derivatives trig function. Okay. Let me find the formula. This guy's. Okay. So the derivative will be, so this is my like u, right? So the answer should be 10 over the square root of 1 minus x minus 9 squared. Let me double check. Yeah, that's pretty much it. The formula you need for this, just go ahead and give it to you. If y is equal to arc sine, the derivative will be 1 over the square root of 1 minus x squared. So whatever x is here goes there. So our x was this, right? That makes sense. Now you could just FOIL that out, I guess, but I think this is good enough for me.
What does that Y say? The next to it? What is that?
Arc.
Sorry, I couldn't see it. I was like, what does it say?
Arc sine of some x.
Okay, there you go.
So this x is here. That's number 15. Okay. I guess so. On Wednesday, if you go over these and if you feel like you are still stuck or you're missing something, feel free to ask me again on any of those problems, or if you have any homework stuff or whatever you like, bring it on Wednesday. So we're just going to review some more. But that's the entire final review, and the solutions are also posted on Canvas. But I'll send you these two just in case.
When does the final have to be submitted by?
Let me check. That's a good question.
Isn't it like the 7th or the 8th?
It's on the home page, the final schedule. So ours is on Monday, Wednesday at night. So it would be evening classes will be given the first meeting of that week. So yours would be on Monday, the first day of so the 6th is when your final would be. I don't mind leaving it open till the 7th, since like I'm gonna do it via what's it called? Respondus. So I don't mind you guys doing it a little later. That's fine. So you can take it anytime.
No,
What's it?
no later than the 7th.
Right. So you can take it anytime between today and the 7th at midnight. Does that work for everybody?
Yeah.
Yes, sir.
Okay. So I'll unlock that today. I guess I'll see you on Wednesday. If you have any concerns or questions, let me know. I'll stick around for a little bit.
I have a question over the exam. What is it? Like the 5th review, the last one?
Huh?
Yeah, on number 6.
For the
So I know-
actual exam, you said?
Not the exam. The last test. The exam 5,
Let me see.
if that's the one. Sorry, I just know it's the last one.
Oh, it's over chapter 5, right?
It's over it's just over the last exam, like the one that we're supposed to have due this week.
Okay, so number 6 on the review, right?
Yeah, no, number 6.
Okay, you want to go through it, or is it
Oh,
specific
yeah, so
question?
I already have it handled. I just want to know just so I don't make a mistake on the test. So when I went through it, I noticed before I got my final answer, I used my 8 and I had to move it to the other side. But like for example, the way I would have like written it in my calculator, I would have put like 12 minus 8, but that would have been positive 4. But it's not positive 4 because it's supposed to be a negative. So if I move it over to that side, like am I just supposed to like automatically like subtract that number by whatever number there is so I know to make sure how to get the right sign?
Well, you need to isolate C. So whatever you got to do to isolate C.
Oh, okay, that makes sense. Okay, thank you. That yeah, I was like, how come I don't get it? What am I doing?
Yeah, well, you just plug in the X and the Y, and then you solve for C, and then you put it
Yeah.
back into the solution. That's it.
Okay. Okay, cool. All right, great. Yeah, thank you for answering my question.
Yeah, no worries.